We're going to be working with fractions, and a fraction is formed by dividing a whole into a number of parts. So this is an example of what a fraction is. The bottom number is called the denominator, and the top number is called the numerator. And that bar represents division. So the bar in a fraction means it's division. The first property is the property of 1. If you have n, any n value in working with fractions, we're going to be using the fraction properties of 1. So if n is any integer other than 0, then if we have n over n, or n divided into n, it equals 1. So you see an example here with numbers. If I have 2 over 2, well, it equals 1. Property of 1. The next property is if you have n and it's any integer, then n over 1 is equal to n, or 3 over 1 is equal to 3. So you have an integer and you want to convert it to a fraction, you could put it over 1. Or if you worked with fractions and your answer ends up being a number over 1, then you need to simplify by simply giving the number. So simplifying fractions, when you're simplifying fractions, you're using common factors. So to simplify fractions, by dividing the numerator and the denominator by the common factors until they no longer have any common factors. So I have this example here of 32 over 40, and I want to simplify the fraction. If I don't know what the highest common factor is, I could divide out the factors that I know they have in common. And when I see two even numbers, I know that I can divide out 2. So I would divide out 2, and I would get my new fraction, 16 over 20, and because they're both even, I know 2 is going to go out of it again, so I would continue to divide out common factors until they no longer have common factors. So I see 8 over 10, that can reduce by 2, and then my simplified fraction for 32 over 40 would equal 4 over 5. So that would be the reduced fraction. And of course, you could always take the fraction and divide out the highest common factor and have your reduced fraction right away. So you don't have to break it into little pieces if you know the highest factor the numerator and the denominator have in common. Then take that factor and divide it out of each, and you will have your reduced fraction. Pause and try. So in this example, I would do the 2, divide out 2 until I got a fraction that was in simplest form. They no longer have common factors. Or I could simply have the highest common factor divided out immediately and get my reduced fraction. Pause and try. So in this case, the only common factor is 7, so I end up getting my reduced fraction is 3 over 4. Pause and try. Whenever I have a 0 in the numerator and a 0 in the denominator, I can cancel them out, and it makes it easier, or a smaller fraction, to simplify. And then once I cancel them out, I'll divide out the common factor, and in this case it's 5, and I end up with my reduced fraction is 5 over 11. So adding and subtracting fractions, when we add or subtract fractions, we want to have the same denominator. If the denominators are the same, we have like fractions. And if we have like fractions, you add the numerators and keep the denominator the same. So here's an example. I have like fractions because both denominators are 8. And because the denominators are the same, I simply add the numerators in this case. So I end up with a fraction of 9 over 8 when I add these two like fractions together. And that is the answer, unless it can reduce. So in this case, I have like fractions because the denominators are the same. So I'm going to add the numerators, and I end up getting 8 over 16. And you're always going to have to reduce your answers when you're working with fractions. So make sure if your fraction reduces that you reduce your final answer. So this solution would be 1/2. Now notice in this fraction I have variables in the denominators. As long as the variables are the same and the numbers are the same, you have like fractions. So with this case, I have like fractions, so I can add the numerators, and I'm going to keep the denominator the same. So I'm going to end up with 10 over 10x. But be careful, because this is going to reduce. The 10 over 10 will reduce, but the x is going to stay. And the x is in the denominator, so it's going to stay in the denominator. And this is going to reduce to 1 over x. Pause and try. Now notice here that I have the same sign, and it's negative minus. So I'm going to add, and I'm going to keep the sign. So I end up with the negative 6 over 8x, and then I'm going to have to reduce. So when you reduce this, you should end up with a negative 3 over 4x. Pause and try. So we end up having different signs, so I'm going to subtract and keep the sign of the higher number, and then I have to reduce my fraction, so we end up with a negative 1/3. So when you're adding or subtracting fractions and they're unlike denominators or unlike fractions, the denominators aren't the same, you're going to have to find the common denominator by using the least common multiple. And if you saw how to find the least common multiple by using the ladder method, that's what we're going to be using here in our examples. So a key note here is, before I look for the least common multiple, I check these two cases. The first case is if the smallest denominator divides into the largest denominator, the largest is the least common multiple. So I always check that first. Does the smallest divide in evenly into the largest? If it does, the largest will be that least common multiple or the common denominator. The next case is if one or both of the denominators are a prime number, and if one or both are a prime number, the only way to get the least common multiple is to get their product, meaning multiply the two denominators together. So remember what prime numbers are. They are numbers that are divisible by 1 and itself, and that's it. So 1, 3, or 1, 2, 3, 5, 7, and so on. Once you find what your common denominator is going to be, then you're going to have to convert your fractions to have that common denominator. And to convert the fractions to have that common denominator, you're going to need to multiply by a number to the numerator and the denominator to get that common denominator or the least common multiple. And once you've done that, you're going to have like fractions, meaning the denominators are the same, and then you're going to add or subtract the numerators. So remember, when your final answer has to be in reduced form, so if you can reduce, you're going to have to reduce the fraction. So in this case, I have 2 over 15 plus 1/3. And I need a common denominator in order to add these fractions. So I'm always checking the case scenarios. Does the smallest denominator divide in evenly into the largest? And in this case, yes, 3 divides into 15. Therefore, my least common multiple will be 15. So what that means is I want both denominators to have a denominator of 15. Now notice in my first fraction, I have that denominator of 15, so I'm just bringing the numerator down. In my second fraction, I need to convert that 3 to be a denominator of 15, so I'm going to multiply 3 by a number that gives me 15, and that's going to be 5. Now, whatever you multiply the denominator by, you have to multiply the numerator by, so that you're converting the fraction but not changing the value of the fraction. So I'm going to end up with 5 over 15 as my converted fraction to have a common denominator so that I can add these two fractions together. Now that we have like fractions, I can add the numerators and I get 7 over 15. And if I could reduce, I would reduce. This next example, you have 3, or you have 2 over 7 plus 1 over 3, and you're looking at the denominators. They're not the same, so I need to find the least common multiple. Both of these denominators are prime numbers, therefore the only way to find the common denominator is to multiply them together. So the common denominator here would be 7 times 3, which is 21. So my common denominator will be 21. So I'm going to have to convert both fractions to have a denominator of 21. So the first fraction I'm going to have to multiply by 3 in order to get the common denominator of 21, and you have to multiply the numerator by the 3 also, so we end up getting our converted fraction is going to be 6 over 21. The second fraction, I'm going to have to multiply the denominator by 7, so I have to multiply the numerator by 7, so my converted fraction will be 7 over 21. Now I can add the fractions together because they're like fractions, and I get 13 over 21. Pause and try. So we want a converted fraction of 12 as the denominator. The first fraction has the denominator of 12, so I'm going to just bring down the fraction. Second fraction I have to multiply by 2, so I end up getting 2 over 12, and now I can add the fractions and I get 7 over 12. Pause and try. So the common denominator here is going to be 66. So I'm going to have to convert both fractions. I'm going to multiply the first fraction by 11, and I'm going to get 55 over 66. Second fraction by 6, and I'm going to get 42 over 66. And I'm going to end up with 97 over 66. And it's not going to reduce, so that's going to be my fraction. Pause and try. So in this case, 4 goes into 8. My common denominator will be 8. First fraction, I do not need to convert. The second fraction, I have to multiply by 2 over 2, and I get 6 over 8. And now you see different signs. I'm going to have to subtract, and I'm going to keep the sign of the higher number. I get a negative 1/8. Pause and try. I'm going to convert them to have a common denominator, and the common denominator is going to be 12. I multiply the first fraction by 4 over 4, and I get 4 over 12, and it's a negative. And then I have multiply the second fraction by 3 over 3, so I get 9 over 12. And see, you have same signs, so you're going to add and keep the sign. So you end up with a negative 13 over 12. So now this next example is where the smallest number doesn't divide in evenly into the larger, or one or both of the denominators aren't prime. So I need to find the common denominator or the least common multiple, and I'm going to use the ladder method. So I'm going to remind you how the ladder method works. So first you're going to take the two denominators and write them in a row. Put a little L-shaped box around the two numbers. And then you're going to divide out prime factors. So when I'm looking at two even numbers, I'm going to divide out the prime factor of 2 and divide it into both numbers, and whatever's left will go underneath. So 42, I get 21, and 18, I get 9. And then I'm looking at 21 and looking for any common prime factors, and in this case it would be 3. So I'm going to repeat the process until they no longer have common factors. So I divide 3 into 21 and I get 7, and 3 into 9 and I get 3. Now my least common multiple will be the numbers on the outside multiplied together. So when I do this, I'd like to multiply the sides together, and I get 2 times 3, which is 6. I multiply the bottom numbers together, and I get 7 times 3 is 21. And then I'll take the 6 times 21 to get my least common multiple of 126. So I want to convert the fractions to have a common denominator of 126. And to do this, you'll see there's a nice little trick with the ladder method. I need to look for the factor to multiply 42 by to get 126. Well, with the ladder method, it will always be the bottom diagonal number. So 3 times 42 will give me 126, which is what my common denominator I want to have. So to do that bottom diagonal number, I'm going to multiply the denominator and the numerator to get that common denominator. So now I end up with my converted fraction as 39 over 126. And with 18, the number I need to multiply by to get the 126 is that bottom diagonal number of 7. So I know I need to multiply the fraction by. So I end up having 35 over 126. And now I have that like denominator, or like fractions, so I can subtract, in this case, the numerators. And notice here I have an even number over an even number, which means my fraction's going to reduce. So now I'm going to have to reduce the fraction, and my answer here would be 2 over 63. So again, the ladder method makes it nice and easy for me to find my common denominator and then the factor I need to multiply by in order to convert the fraction. Pause and try. So again, I like to use the ladder method. I'm writing the two denominators in a row. I'm dividing out common factors, and I end up with least common multiple. And again, I do the sides first. 4 times 15 will be 60. I have my common denominator, and now I'm going to convert the fractions. I'm going to multiply the first fraction by 5, the second fraction by 3, and now I can add the numerators, and notice I can reduce, so make sure you reduce. And I reduce 2 out first, and I see that they're still even over even, which means I need to continue to reduce until they no longer have common factors. So my final answer here will be 7 over 15. Pause and try. So again, I'm using my ladder method. I'm dividing out common prime factors until they no longer have factors in common. And then I'm going to multiply the side numbers together first, bottom numbers, and then multiply the two together, and that will be my least common multiple. So my least common multiple, or my common denominator here, will be 48. The first fraction I'm going to multiply by 3, my second fraction by 2, and I'm going to end up having negative 13 over 48. So be careful, we have different signs. I'm subtracting and keeping the sign of the higher number. So whenever you're adding a whole number and a fraction, and this is an example of a whole number plus a fraction, you have to have fraction to fraction. So the first thing you want to do is use that property of 1 and put that whole number over 1 so that you have a fraction plus a fraction. Now with fractions, you need a common denominator, and the common denominator is always going to be the denominator of the fraction. So I need to convert the 3 over 1 to have a denominator of 7. So my least common multiple, or my denominator, is going to be 7. So I have to multiply 1 by 7 to get a denominator of 7. So you're going to have to multiply the 3 by 7 also. And we already have the 7 in the fraction denominator, so I just bring down the 6 over 7. Now I have fractions that are like, so I can add the numerators, and this would be the answer, 27 over 7. Pause and try. So again, I'd like to put that over 1. I'm getting a denominator of 10, so I have to convert the 8 over 1, so it's 80 over 10, and then I just bring down the numerator, which is 1, and I do the subtraction here. So my answer would be 79 over 10. Pause and try. So again, I'm putting that over 1. My denominator is going to be 11. I keep the first fraction. I multiply the second by 11 over 11. I have my converted fractions, and I do the subtraction here. My answer would be 72 over 11. Now, in this case, you see I have denominators with variables in it, but the variables are the same, but the numbers aren't. So I'm going to need to find the least common multiple for the numbers. And again, I would use the ladder method, and I would find that my least common multiple for 12 and 18 would be 36. But I also need to keep that variable in the denominator. So I'm going to keep the variable in the denominator. So now I need to convert my first fraction. So I'm going to multiply by 3 to convert the first fraction to have a denominator of 36x. And then the second fraction, I'm going to multiply by 2 to have a denominator of 36x. And now I'm going to subtract the numerators, and I'm going to leave my variable in the denominator. So we end up with 19 over 36x. So now we're going to multiply fractions. And whenever we're multiplying fractions, you don't need a common denominator. Multiplication of fractions, all you do is simplify and then multiply across. So the first thing you want to do is when you're simplifying, you want to make sure that if there's a common factor in the top that has it. Now we're going to work with multiplying fractions. Now a key note with multiplying fractions, you do not need a common denominator to multiply fractions. So when you're multiplying fractions, you want to first simplify. And what simplify means is if you have common factors that are in the numerator that have the same common factors that are in the denominators, you want to reduce them out. Meaning if I have, in this case, 5 goes into 5 once, and then 5 could also go into 15 3 times. So what you're doing is you're dividing 5 by 5, whatever's left you put on the top, which would be 1, and then I'm dividing 15 by 5, that common factor, and I'm left with 3. And then I also see that 4 goes into 4 once, and 4 goes into 8 twice. So I'm reducing everything before I multiply, because if I don't reduce first, I'm going to end up with a very large fraction that's going to need to be reduced in the end. So you always want to simplify as much as possible before you multiply. And then to multiply, you always multiply across, meaning multiply numerator to numerator and denominator to denominator. So I multiply the numerator to numerator, which is 1 times 1, so I get 1, and then denominator to denominator, 2 times 3, and I get 6. So my solution here is 1/6, and it's a reduced fraction. Pause and try. So I simplify first. 3 goes into 3 once, 3 goes into 30 10 times, 8 goes into 8 once, 8 goes into 32 4 times, multiply across, 1 times 1 is 1, 4 times 10 is 40. So my answer here is 1/40, and it's a reduced fraction. Pause and try. So notice here, 5 goes into 5 once, 5 goes into 15 3 times, 3 goes into 3 once, 3 goes into 12 4 times. Don't lose that negative. We end up with a -4 over 3. So whenever you're working again with a fraction and a whole number, with multiplication, you always want to make sure you put that fraction over 1. It makes it easier to do the multiplication and to know if it's in the numerator or the denominator. So put whole numbers over 1. Once it's over 1, then you simplify and multiply across. So in this case, 16 goes into 16 once, 16 goes into 32 twice, I multiply across, and my answer here would equal 5 over 2. Pause and try. So in this case, I put 18 over 1, I simplify, and I multiply across. Now notice here, I end up getting 16 over 1. You can't leave something over 1, so your answer would simply be 16. Pause and try. So in this case, I put 18 over 1, I simplify, and I multiply across. Now notice here, I end up getting 16 over 1. You can't leave something over 1, so your answer would simply be 16. 16. So your answer would simply be 16. Pause and try. So I'm putting that negative 8 over 1. I'm going to simplify and I'm going to multiply across. So I end up getting a negative 3 over 2. Don't lose your negative signs when multiplying fractions. Now, a key note here is reciprocals, and reciprocals are really important. So when we're talking about reciprocals, when two numbers are multiplied together and their product equals 1, they are reciprocals of each other. So you notice here I have a fraction 3/4 and it's being multiplied to 4 over 3. And if I multiply them, again, if I use the rule, I simplify first and multiply across, I'll end up with 1 over 1, which equals 1. Therefore, reciprocals for a fraction is simply taking the fraction and flipping it over. So you see 3 over 4, a reciprocal for 3 over 4 would be 4 over 3, because when I multiply them together I get 1. So a reciprocal to a fraction is simply taking the fraction and flipping it over. So when we're doing division of fractions, we're going to need to use that idea of reciprocals. And how it works is you take the reciprocal and flip the second fraction. Before you do anything, you have to flip the second fraction and change the division symbol to multiplication. So division problems turn into multiplication problems, but you have to create it by flipping the second fraction. So you keep the first fraction, change the division sign to multiplication, and then get the reciprocal of the second fraction. So the key thing is keep the first fraction, change it to multiplication, and flip the second fraction. And now it's multiplication. You're going to simplify what you can simplify, and notice here in the 18 and 15, what reduced out of there was a factor of 3. So they both had a common factor of 3, and I divided it out of each. I was left with 6 and 5. And then 7 goes into 14 2 times, so I'm left with 2, and then I end up multiplying across. So 2 times 6 is 12. 1 times 5 is 5, so my answer here would be 12 over 5. Pause and try. So again, keep the first fraction, change it to multiplication, and then get the reciprocal of the second fraction. Now that we have it as multiplication, you're going to simplify and you're going to multiply across. So we end up here at a negative 5 over 6. Pause and try. Remember, keep the first fraction, change it to multiplication, get the reciprocal of the second fraction, simplify, and multiply across. So we end up with 9 over 8. And just like multiplication with division and whole numbers, you always want to make sure you put the whole number over 1. So put the whole number over 1, especially with division, and if it's the second number. If it's the second number, you're always going to have to get the reciprocal. So again, keep the first fraction, change it to multiplication, and then you're going to have to flip the second fraction. And in this case, that whole number 8 turns into 1/8. So it's very important you put whole numbers over 1. And then simplify here and multiply across. So you end up with your solution here would equal 2 over 25. Pause and try. Putting that fraction or that whole number over 1, keep the first fraction, change it to multiplication, flip the second fraction, simplify, multiply across. Your solution here is 2 over 7. Pause and try. Again, I'd like to put that whole number over 1. I'm going to keep the first fraction, change it to multiplication, flip the second fraction, simplify, multiply across. Your solution here is a negative 10 over 3. So now you notice, so this next example, we have variables in the fractions. So it's not again, not addition, so we don't need common denominators. So I'm going to simplify. The first thing I do is simplify. I'm simplifying the numbers here. But if I have the same variable on the top as on the bottom, I can reduce them out. It's just like common factors. So they're going to cancel out. And then I multiply across, and my solution here would end up being 4 over 45. So if you have the same variable on the top as on the bottom, they can reduce out. Pause and try. So again, I'm simplifying first, and I see that 3 comes out of that 15 and that 27. I'm going to multiply across, and my solution here is 20 over 63. Pause and try. So again, I'm keeping the first fraction, changing it to multiplication, and getting the reciprocal of the second fraction. I'm going to simplify first, and then I'm going to multiply across. Now be careful here, because in the denominator, that y is not going away. So it's going to end up being in my answer. I'm left with 4 over 9y. So now we're going to talk about some complex fractions. And complex fractions are a fraction over another fraction. So we have a fraction in the numerator and in the denominator, and this is what it would look like. So I have 5/6 over 2/3, and this is a complex fraction. But what I need you to remember here is that that division, that line represents division. 5/6 is being divided by 2/3. So if I just write my complex fraction as division of fractions, then I know how to solve the problem. So take the top number, or the fraction, write the division sign, and write the bottom fraction. Now you know what to do. You're going to keep the first fraction, change it to multiplication, and get the reciprocal of the second fraction. Simplify, multiply across. So complex fractions are simply division of fractions. Pause and try. So I'm just setting it up as a division problem. I'm going to take it and I'm going to flip the second fraction and change it to multiplication, simplify, and I'm going to multiply across, and my solution here is equal to 8 over 15. So notice here that I have some operation of fractions on top and operations of fractions on the bottom. This is a complex fraction. But in order to do the division of complex fractions, you have to have just one fraction on top and one fraction on the bottom, which means you're going to actually have to perform that operation. So you're going to have to do the addition here of fractions. And whenever you add fractions, you need a common denominator. So our common denominator, in this case, because 3 is prime and 3 doesn't divide into 4, the only way to get my common denominator will be to multiply the two numbers together. So my denominator would be 12. So I'm going to multiply the first fraction by 3, the second fraction by 4 over 4, and I'm going to have my converted fractions. So I'm going to convert it, and then I'm going to be able to add. So the top fraction, after doing the addition, will end up being 10 over 12. And the second, the bottom fraction, I want to get it to be one fraction. I need a common denominator, and notice that 6 divides into 12, so my common denominator will be 12. So I need to convert the second fraction by multiplying by 2 over 2. So now I have my common denominator, so now I can do the subtraction in this case, and I get 3 over 12. Now I converted it into a complex fraction where I have one fraction over one fraction. So now I can write the top, divide it by the bottom, and do the division of fractions here. Keep the first fraction, change it to multiplication, flip the second fraction, simplify, multiply across. So my solution here for this complex fraction would be 10 over 3. Pause and try. Again, you need to get a common denominator. 5 divides into 15, so my common denominator will be 15. So I get 4 over 15 minus 9 over 15, which equals a negative 5 over 15. The second, the bottom part, the common denominator, I'll have to multiply the two denominators together, so I'll end up with the common denominator of 12. So my converted fraction would be 8 over 12 plus 3 over 12, and I end up getting 11 over 12. Now I have a complex fraction that I can work with. Again, it's the top divided by the bottom. Don't lose your negative sign. And then you're going to have this, keep the first fraction, change it to multiplication, flip the second, simplify, and multiply across. So now be careful here, because when I simplified, I end up having 5 over 5, which reduces, so you end up getting your solution is a negative 4 over 11.